Good evening and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here, and it's great to have such a nice crowd here. I also want to welcome those watching on our live stream. And for those watching on the live stream, when it gets to a point where you've got some questions that you'd like to ask the team, put that information in the chat, and we will pass it along. Let's see here. I see a number of people that have familiar faces. Just as a show of hands, who's here for the first time? You know, just a couple of people. All right. And who here are members? All right. Excellent. Excellent. Well, for those that don't know, Kopernik belongs to an association called the Association of Science and Technology Centers. It's a consortium of over 350 other science centers that honor each other's memberships. And so your Kopernik membership gets you into here for free, but also gets you into 350 other science centers. So this is the kind of place you like. Getting a Kopernik membership really is a good value. Let's put it that way. Couple things going on here. So again, every Friday night we do a public program. Tonight is going to be the Southern Tier Robotics competition robot. Next, let's see here. Actually, we don't have it up on our website yet. Well, actually, yeah, I can go find it. It's our public programs, upcoming Friday night programs. So tonight's the robotics. Next Friday will be another one of our Kopernik educators, Robert Olaf Seegers, talking about Neptune and the last real planet. Okay, he's good. Okay, so I have this thing. I know people are really upset about how Pluto got demoted to being a dwarf planet, and you know it just doesn't act like every other planet. But I contend that if they called it anything else than Pluto, they call it Aldon, nobody would care. But because it's got the same name as that cute little dog, like they're all up in arms about it. But anyway, so we'll talk about Neptune, and then finally, at the end of May, most likely Jeremy will be doing this, but this be doing a Summer Skies, giving you sort of a tour of what you can expect to see in the coming summer months. And we're starting to line up our speakers for the remainder of the summer. So stay tuned for that. Other things that are coming up, for those that are in a position to do so, we actually are going to be hosting a Red Cross blood drive on Tuesday, May 30th. Well, let's try that again. And but then right after that is Rocket Fest, and this is an opportunity for families, adults, whatever. That want to build those Estes rockets. You'll pick up a rocket either here at Kopernik or at Barnes & Noble on the 19th or the 20th of this month. Sign up for a launch window, and then you'll build them at home. If you're having some issues, we'll actually offer a Zoom consultation session on a Saturday morning, and then you'll come up here. We'll check out your rocket, and then you get to launch it. And these rockets will go, depending on what engine we put in, between 500 and 1,000 feet, and we get practically all of them back. So that's another bonus there. And then finally, to bring to your attention, summer camps. We have a very strong summer camp program, and for students entering second grade up through high school. Most of the younger camps are already full, but our middle school and high school camps still have some openings. We actually have a great new camp on Introduction to Astronomy that we're really looking forward to offering. We also have a high altitude balloon camp where the students will build a payload that will then put on a weather balloon that'll go up to over 100,000 feet. We'll track it, and then when it returns to Earth, we'll grab it back before the Air Force shoots it down. Anyway, one of the things I really love about Kopernik is that it really offers an opportunity for us to learn throughout throughout our life. We offer programs for kids as young as 3 years old in our Kopernik Kids class. We have, as I said, our summer camps. We do school outreach. But these Friday night programs are really an opportunity to really promote lifelong learning. And what I'm really excited about, this is probably the 4th or 5th year I think we've had your Team Heck. Yeah, exactly. I think you were doing it when you were actually still a student there, Drew. And it really is amazing what a team can do in a very short period of time. And so what I'm going to do is I'm going to step away here and introduce you to Drew Williams, who is the technical lead on Southern Tier Robotics competition robot. So Drew, take it away, and we're going to get your PowerPoint up.
Yep. Hello, everyone. I'm Drew Williams, the lead mentor for Southern Tier Robotics, and I just want to give a quick introduction to our team before the kids take over the presentation and tell you guys about the robot that we built this year. A little bit about the team. We build a robot to compete in a competition called First Robotics Competition, which is a worldwide high school robotics program designed to teach kids about STEM and technology and everything like that. If you've been here a while, we were formerly called Tigertronics out of UE, and during COVID, we switched to from working out of Union Endicott schools to Vestal because almost all of our students were from Vestal at the time. And we changed our name to Southern Tier Robotics to try and reflect all of the schools that we want to get involved. So our team is pretty old. We had, I think we started in 2007, and I was a student on the team in my freshman year of high school, and now I've mentored throughout college, and now I'm the lead mentor after the head mentor stepped down in 2020. So yeah, I think Southern Tier Robotics is really all about having fun and competing at the same time. We try and build our robots to be competitive against all the other teams, and and we're also actually more recently this year we're trying to expand into other areas, not just building the robot, but doing more community outreach events like these. And we're going to talk more about one of the summer camps we're running this year at the Vestal Library. So I'm going to hand it off to, I think, Anne, right? Yeah. If you want to take over from here.
Before I start talking about what we do, I just want to introduce everybody. Hi, my name is Ann Coleman, and I am the student leader for Media and Business.
My name is Aiden Luker. I'm in 10th grade, and I've been on this year for 2 years. Drive team last year and this year.
My name is Izzy Smith. I'm a 9th grader, and I was on drive team this year.
My name is Luke Sobel. I was recently promoted to the electrical lead this year. I'm in 9th grade.
My name is Samuel Winans. I'm in 9th grade at Vestal High School, and I am one of the 2 co-captains of the Southern Tier Robotics team.
I'm Evan Ferran. I am the lead on the fabrication team, and I've been part of this team for 2 years and work on the pit crew side of the team.
So our team has been very busy recently. We just finished up our competition season. So the way our particular competition works is we have a fall prep season. So we start in September. We meet once a week. until January, which is when First releases their game for the year. So that's like our official challenge that we are going to compete with. From January through until April, we practice almost every day to build our robot and make sure it can complete the challenge. And after April and through to June, we work on cleaning up our shop and improving our robot design so that we can better compete in competitions later on. Some of the competitions we competed in 2 competitions this year. We competed in Rochester, which was at RAT, and Pittsburgh, which was in the gigantic convention center down there. It was really, really cool. So right now we are practicing in Vestal High School, and we have our own room, which was the old wood shop. So we have a lot of our own manufacturing equipment, and we also have access to a very large computer lab and multiple 3D printers, and we're always working on with all of that equipment, and we're learning a lot. This is a team picture from our Pittsburgh competition. This was our 2nd competition this year, and this was our first day of competition. So competitions are 3 days. The first day is practice. That is why we are not all wearing our uniform, but we're about to go in for that picture.
So, So, as Drew previously mentioned, the robotics competition is led by the FIRST organization, and their main goal is to teach kids STEM and get them into engineering. So they host a robotics competition globally that has high schools from all over competing and playing this game that changes from year to year. So this is the field from this year. We have the spectators up there. On the left and right sides, we have the drive stations, and that's where the team controllers work, and they'll maneuver the robot through the challenges and everything, and they'll basically trying to pick up these cones and cubes and put them into these scoring stations on the left and right side. That's about it. About the field. All right, so this year, and every year actually, we have 3 subdivisions of our team. We have the drive crew, who they operate and control the robot, and they're the ones responsible for how the team performs in the match, and they will drive the robot. We have Aiden and Izzy as operator and driver, and we also have a technician and a human player. We also have another crew that we have is the crew, which their goal is to just repair the robot when it breaks eventually. And well, they get beat up during the matches. They run into each other during times and everything like that, but yeah. Do I really need to use this? I can speak loudly without it. It's easier. So, it's easy. No. Jeez. Alrighty. So this was our robot from this year, and as you can see, the intake system is a little bit different. That was the original system. It worked pretty well, but we replaced it with this upgrade. We also have a scouting division where we have maybe about 1/3 of our team, would you say? And their goal is to just watch the other matches and determine which teams are strong in certain areas and just prepared for certain matches. And they incredibly useful to the outcome of the game, I guess.
So we're going to play a couple videos for you. The first one is our game video. So it's the video that was released in January. That was our challenge that we had to build our robot to compete for. So do you want to...
Welcome to the 2023 First Robotics Competition game, Charged Up, presented by Haas. 2 alliances of 3 teams each compete to score cubes and cones into their grid to charge up their community. The alliances earn additional points if their robots are docked to or engaged with their charge station. Robots start each match in their community and may be preloaded with either 1 cube or 1 cone. Each alliance may choose where to stage 4 additional game pieces. During the first 15 seconds of the match, robots are autonomous. Without guidance from their drivers, robots score preloaded game pieces, collect and score additional game pieces, and are docked to or engaged with their charge station. Charge station points earned during auto count towards a potential activation bonus. The grid has nodes specific to cones and cubes, and some where either a cone or cube can be scored. During the remaining 2 minutes and 15 seconds, drivers control their robots. Robots continue to collect cubes and cones from human players at their substations to deliver power to the grids in their community. Each community contains 3 grids. The center grid is the cooperation grid. A link is a line of 3 game pieces scored on the same row. Completing enough links earns the alliance a sustainability bonus. If each alliance scores at least 3 game pieces in the cooperation grid, the sustainability bonus threshold is lowered for both alliances. Robots are protected within their community and loading zones. As time runs out, robots race to their charge stations. Alliances earn points for each robot docked to or engaged with the charge station. Earning enough charge station points earns the alliance the activation bonus. The alliance that earns the most points wins the match.
So that is the video that is given to us on in January when our build season officially begins. And our drivers, Izzy and Aiden, are going to talk about a video that we have starting soon, hopefully, of a match that we competed in. So one of the robots on the field will be ours.
Okay, so we are beginning our autonomous period where the driver and operator are not allowed to touch their controllers and have to stand behind the white line. Our autonomous scores a cone on the top cone node and moves in front of a piece which we'll pick up in the very beginning of tele-op where we are allowed to step forward and pick up our controllers. I am the operator, which is the player who controls the intake system of our robot. I have preset buttons on a controller that move to a coded position for the high scoring node, middle scoring, and low scoring. I have a preset for ground intake to pick up ground pieces, and a preset that moves to the height for the double player station, which is up in the top right corner for us, where our human player loads pieces into the game for us to pick up and take back to our scoring grid. I have 2 intake buttons, one that spins one way that takes in pieces, and one that spins the opposite way to spit out pieces for us to score.
I am the driver. I control which way the robot goes, how it spins. My left joystick controls the direction it moves in. My right joystick controls which way it spins. I also have presets that control the spin of the 90 degree, which is A, X, Y, B buttons. The middle can get pretty chaotic sometimes, running into your teammates or enemies. You have to be careful about that, because if your robot accidentally goes into the other robot, enemy's robot, you'll get penalties, which will give the enemy team more points. And driving through the middle, if you notice the double player station is full, you can try to play defense and slow down the enemy's cycle time until you get a slot to open up to get a game piece to try to score. And our arm wasn't working for some reason, so we didn't grab a piece, and then we drive back to our engage. We go to do a double engagement because we know time's starting to run out. We get it easily. Step back, set our controllers down so we don't actually hit a button and ruin the engagement. And we just wait to see if the enemy team gets their robots engaged. Clear victory by over double.
So we are on the blue team for this match, so we did win. So part of first is that we are on a different team with different teammates every single round. So we have different people on our team every time. So we have some pictures from our last competition. So here you could see that this is how we place our robots at the beginning before everything is set up. For autonomous, we are allowed to go on the field and set our robots in place and manually put in the game piece. In the top corner, you can see our human player is controlling the black sliding thing so that we can help get the robot to pick up the cone. After that, we have to dodge other robots as we get across the field. And then our drive team has to place the cone onto the pipe, which is a little harder than it looks.
So these are some photographs from our pit crew, and in pit crew, essentially your goal is to repair the robot as quickly as possible. So sometimes we'll have mechanical failures, or we'll get run into, and something will break, and our job is pretty much just fix it as fast as you can. We have a couple pictures of our entire pit crew working on the robot there, and yeah, it can get kind of stressful sometimes, but we tend to have roughly about half an hour between each match, about half an hour to an hour, so most of our problems can be fixed relatively quickly.
And the pit is a tiny space too. It is a 10 by 10 square, people. Like, we have no space. We have a lot of stuff in there. It's kind of crowded. Just a little. So here's some pictures of our team just doing things that aren't necessarily part of robotics, but definitely fun. We really become a really tight-knit community throughout the season. We spend a lot of time together, and we have a lot of fun just being teenagers.
So we're basically, we want to do this community event because we want to reach out to the community and let you guys know that we are happy to have anyone on the team that's from grades 9 to 12 and they have to go to Vestal. I know a lot of people obviously don't go to Vestal High School right now, but we're working with the school district to try and get other schools involved. But it is a process, so yeah, so it will take a while, but hopefully we'll get there. And we're also always looking for new mentors to become involved with the team. You don't have to know anything about engineering to be a mentor or to be a student. That's what we're here to teach you. I know Art Lau, new mentor this year. He was an engineer, but he's a mentor that does a lot of the business and outreach stuff, and that's been hugely helpful this year. So really any help is appreciated. I think that's it. Next slide, maybe. Yeah, so we have a team website where you can go and check out our schedule, and there's an email where you can get in contact with us if you have any questions about mentoring or your kids joining.
Hang on. Okay. So, recently our team has been in contact with the Vestal Library, and we will be running a STEM club for that in collaboration with them. So every third Tuesday of the month from 5:15 to 6:15 p.m. I only got that email this afternoon. I'm sorry, I didn't have time to change it. We will be doing STEM activities for grades 4th through 6th. So this next upcoming month, we will be learning about batteries and how they work, and we'll be making a battery out of coins, which is really cool. We just tested it. It was really cool. There is pre-registration, so if you're interested, make sure you check the library's website. Stuff fills up fast. But yeah, we're going to learn about lots of other stuff. After next month, we're looking at stuff like DNA and acids and just all kinds of stuff. So now we're going to do a demonstration, and Evan is going to talk about some of the parts of our robot.
Oh, great. Thank you. So with our current design this year, we have 4 motors on each corner, and they are a complex system of gears and wheels and everything, and it allows the robot to move in any direction, whether it's diagonally, backwards, forwards, just any direction. It's been extremely helpful this year. And so we also have, this is the intake system, the Mark II, which works a lot better, I've heard. And some nice LEDs. So this arm, as you'll see in a minute, will be able to extend out about 4 feet or so, and it can pick up the cone or the cube and just quickly place it down anywhere very quickly and efficiently. What else? We have 50 pounds of weight here to counteract the tipping, since the arm goes out really far. But the whole robot in general weighs about 120 pounds or so. And usually it has a row of bumpers, and that protects the robot from most of the damage of just getting knocked by other teams. But right now we don't have those, but this way you can see all the components. Drivers? Okay. So as you can see, the motors allow any direction, any orientation, and quickly can be rotated. Right now we have it on a slow mode for everyone's safety, but figured it'd be better than taking out some ankles. On the back, there's a camera right there, and it can help. Originally, it was there to help the operators see what they're doing and everything, but it was better to not use it. Aiden, you want to test out the intake? Please don't take my hand off. You want to try and get it from here? All right. All right. Yeah. All right. So essentially we have a few motors up top which will spin a lot of wheels really fast and will suck up pretty much anything you throw at it. Oh yeah. Yeah, that's a good idea. Oh, he said put it on the ground. All right, here we go. I give up. We'll do the cone. You want to do a cone from ground? Or cube? I don't know. There we go. But it didn't go very well. We have this blinking light over here on you want to do a pickup from the ground? Please don't break it. Oh. Yeah. So, I guess that's about it.
So the reason we can't pick it up from the ground right now is that our robot is set for our other intake. So the one that was on in the video and most of the pictures is what it's coded for right now. We didn't change the code, so it's too close to the ground. But does anybody have any questions?
Wait a second. We're going to bring the mic over here so that the people on the live stream can hear it as well.
When you go to a competition, do you have a second one to back this one up if something happens to it, or you just have the one?
So generally, we have just this one robot.
Sorry.
Thank you. So usually we'll only have the one robot. However, we'll have many spare parts that we bring with us, which we can quickly, and we have the robot designed so that we can quickly interchange the spares for any broken pieces. And if a piece is broken but still fixable, we will just fix it on the robot and send it back out. So.
Any other questions? Have one over here.
What was the biggest challenge your drive team faced and had to overcome, and how did you overcome it? And also the same thing for the pit crew, if you could answer that as well.
Our biggest challenge on drive team was probably when our robot broke or wasn't working correctly, so we had to adapt. Like there was one match where my controls were inverted, and that was pretty difficult, but we were able to work with it and win the game.
For pit crew, I would say our biggest challenge that we had to overcome was the tight size of the pit station. we had a lot of people working and not a lot of space to do it. So we were able to work through it, and with a lot of cooperation, we were able to get through everything and fix everything very quickly. But I'd say that was our biggest challenge that we overcome.
I just wanted to add something to the drive team part. I'm the drive coach of the team, so that means that I talk strategy with the other drive teams, and we formulate what's best for our team during that match, or our alliance during that match. So when something goes wrong on the robot, it's my job to tell the actual drivers, what to do. And I talk with the other teams during the match, saying like, "Oh, our robot broke. We need to pivot our strategy." So instead of going to pick up cubes from the player station, for example, we might try and play defense if our arm doesn't work, or try and go balance earlier in the match. So our drive team this year was really good at adapting to all the situations. Like, for example, the time where the controls were inverted, I'm honestly surprised we got any points at all with how hard it is to drive like that. So I was super proud of the drive team.
Oh, got another question?
Yeah, where do you get the parts, and do you have a budget of some sort, and if so, where's the money come from?
Yeah, I'll answer that question. So a lot of the parts, well, for example, so all of the aluminum chassis pieces and the arm superstructure pieces are from just stock that we order, but for example, the motors and the battery and the electronics, you can only use certain parts that are approved by the game manual. So this motor that controls the elbow is an approved motor. And so the next part of that question is the budget. So we got a large grant from Vestal High School last year to buy all of the machines and turn that wood shop that wasn't used into a full machine shop. And we were able to get robot parts with that, but we've already blown through that budget for the machines and everything that we needed just to get up and running. So right now we're doing fundraising from local sponsors. In the past we've been sponsored by Lockheed Martin, BAE, and different engineering companies, because getting engineers that grew up in this area to go work for them it's a good incentive to give money to us. So that's what we're doing.
And you would be one of those engineers?
Yeah. Yeah.
I have a question. You talked earlier about the STEM club at the Vestal Library. Do you have to be a Vestal resident, or is it open to anyone in the area?
And that's Anne's question.
That is open to anyone who applies and shows up, as far as I know. So.
I was going to say, I have a couple of questions. So, who can tell us about sort of what kind of computers and how do you communicate? And did you ever have problems having your communication channel interfere with somebody else's, or somebody else's with yours?
Drew can help answer this one too. He knows a little bit more about this than I do.
Our main programmer this year couldn't make it today, so as the programming mentor, I'll help explain. So the computer on the robot is a Linux computer that has a FPGA attached, which allows you to hook up to different sensors really easily and read those values. And the robot is controlled over Wi-Fi just with a router that FIRST provides, and it connects to either the field when you're at competition or just a regular Wi-Fi at home. There haven't been really any interference issues with the competition robot, but if it's more, I guess, coding issues that happen with the robot. So like for example the controls being inverted, or one time our robot drove to the other side of the field because it thought it was on the wrong alliance because of the camera on the robot. So that was a bug. But yeah, there's lots of different things that can go wrong. So a big part of the building a robot is making sure everything is robust to different environments and changes.
Any other questions here? Trying to think. There's. You talked about that it's a Linux computer. Is it a Raspberry Pi, or is it something sort of a little up from that?
So it is it's ARM, so it's the same architecture, but it is it's called a Robo-Rio that only National Instruments sells, and they only sell them to first teams, so it's kind of a specific thing. But it's similar to Raspberry Pi, but with more inputs and outputs you can use.
Now, I recalled also that in previous competitions that sort of battery management was also sort of something. Can you guys talk about how that's been and what improvements have you used over the years?
So at the moment we use I believe a 12-volt battery here, and this is where we have it here, and we have it carefully strapped down. But for the most part, we haven't had too many battery technical difficulties. I don't believe this season we've had any. Last season was another story, but for the most part, we switch the batteries out every match, and that way we can always have a full charge and really have never run into many problems. We do have a yellow safety guard here, which prevents the robot from being turned off by a cone or something falling on it, which has been pretty important and pretty helpful. That's about it.
Oh. Yeah. They asked the FRC on the shirt, meaning is that the first robotics? Oh, on the side and the team number, right? So I noticed also that sometimes you got a blue bumper, and other times you have a red bumper. So that talk about what they call the alliances.
So the color bumper that we have indicates which team or alliance we are on for the specific match. So it changes back and forth between pretty much every match we're in, and each match the alliance, the teams on the alliance change, so you never know who you're going to be working with. You don't really have rivals at these competitions because you're teammates with everyone and you compete against everyone.
So, I'm sorry, we got a question back here.
I was just curious. I'm pretty loud. Everybody can hear me. Oh, okay. You guys can hear me pretty good, right? I was curious. You played us the video where they assign the task. So what does your collaboration process look like when you're coming up with your design? Once you see that video, how does that work?
So basically how it works is we'll have a meeting the day of the announcement. It's a huge event. A live stream is set out by FRC where they'll announce what the game is, and as soon as it's announced, we immediately jump on to starting prototyping, ideas. Anything that comes to mind is drawn out, thought through. It's given the space that it's needed. And mainly the first couple of days are really all just coming up with our ideas that we want, or that we think could be possible, and then we'll spend the next several days kind of eliminating those ideas, changing them slightly to better fit what exactly we want to do. And during that time, we'll also start to get our game strategy and how we think we're going to want our robot to be able to interact with the things on the field. Then we reach the point where we'll start kind of prototyping certain designs, and we'll make them out of cheaper materials like wood. And from there, we start, once we finished our prototyping and get a final design, we will, at the same time as we're prototyping in real life, we'll also be changing things on a computer-based program. From there, once we have our official final design, we will make it out of real parts. But we really never have an official design. we're constantly changing it to better fit and better adapt to the playing field and what we need it to be able to do. So that's kind of how it works.
Any other questions? I love this stuff. So all these questions keep popping into my head. So the computer programming. What language do you use? And can somebody talk to us about sort of how you program for the autonomous section of your of the program?
Yeah, I'll talk about that. So our programming language that we use on the robot is C++. Using all modern C++ stuff. We actually had a really cool ARM trajectory generator that was written in Python. So instead of just telling each joint to go to a specific angle, we actually, because that can lead to the arm like trying to crush itself, or non-optimal movements where the arm is going to go way out or over the height limit set out in the rules. So we programmed a Python program that would generate specific arm trajectories that didn't violate any of the constraints, like the height limit or the extension limit, and made sure it doesn't run into itself. And that used a fancy technique called numerical optimization. And that was new for us this year. It was cool. It worked out well. Our arm was probably one of the most smooth moving ones I've seen, especially with the old intake, because that was lighter, so it didn't have as much jerking motion. And so for our autonomous routine, we had a camera on the front of the robot that would detect, if you saw in the game video, they had those weird looking tags on the node. Those are called April tags, and you can understand them with a computer to say, oh, this is tag 1, and it's always on the same spot in the field, so you can calculate your robot's position on the field using that data. We didn't get it fully working by competition this year, but hopefully in the off-season we're trying to get our robot's position to be known at all times within 1 or so inch of accuracy based on the April tag data, and combining the data that we get from the wheels saying how far each wheel has moved, because you're able to calculate the robot's position based on that as well. So you can say, like, go to this point on the field, move the arm out, and then score a point. That's kind of how the autonomous works. So we program it in like steps.
All right. Unless there's any other questions, I want to thank you very much for bringing your robot up here. Again, every year it's a completely different robot, because obviously it has to do different functions every year, and but also it's great to see how you keep learning from year to year. Plus, also, I guess they changed some of the rules or whatever, but you pick up from stuff that you did last year, and I would imagine you also probably, in talking with some of the other teams, sort of see what they're doing, and and think about, hey, is that something we might want to consider, as part of next year's design.
Yeah, that's one of the big upsides of the cooperation part of FIRST. So it's a combined word of competition and cooperation. So there's a website that a lot of the FIRST teams use to talk to each other about what they're building, and seeing different techniques that we can use. So one of the examples of that is this improved intake. We saw a lot of teams doing this design where it would suck up the cone, like by alternating this direction of these wheels. And we haven't thought of that before our competition, so it ended up working a lot better than the other design we had, and we wouldn't have known without working with other teams.
So how many cones and cubes did you go through?
I think we popped a lot of our cubes. and but we didn't break any cones. They're pretty tough. They're made of like a thick rubber.
A wood shop is not a good space for soft inflatable objects.
I mean, it is because we do have the tape to tape it back up, but once you reach a certain level of tape, it just doesn't work anymore. So.
Got a question over here. Oh, we have a question here.
Have you ever accidentally shot a cube or a cone out of the robot arm?
Let Izzy. The operator.
Okay, so,
I don't think so during a match, but definitely during practice.
at matches, I've hit the eject button before perfectly centered over scoring platforms, and that's kind of throwing the pieces at the polycarbonate in front of us, which is scary, but like it's not gonna do anything to us. And I've thrown a few cubes and cones at people in the workshop, accidentally.
We've also had quite a few collisions of people and the robot when people were learning how to drive. It is learning how to operate the robot with the swerve drive is different, and sometimes there are some crashes.
If you're willing to help us, we're looking for investors for shin guards for the entire team for practicing. So please, if you have any extras to spare us.
So maybe you need those little bumpers for around the team members as well, along with the. It's interesting. Again, this year's competition, you had to at the end of the competition, you had to get onto that raised, whatever. Also, it seemed like it's something where you actually had to sort of collaborate with the other robots that were going to be climbing on there, because it was basically, if you needed to let the other one on, you had to go to the end.
Yeah, so that was a big part of the strategy before the match. So we would talk with our alliance members. We were a pretty wide robot, so during our strategy talks, we would say, "Oh yeah, we'll drive up first, and we'll hold it down for you guys to drive on." And then once we're bounced, we can scooch off the side halfway to allow for more room. And also a big thing is timing, because you get a lot of points if you all three bounce at the end. So if we wanted to go for the triple bounce that round, we would give ourselves 45 seconds, 30 seconds. Because
out of the 3 minutes or so you've got.
Yeah. So it ends up being. Obviously, during the playoff matches, you want to cut it as close as you can to keep scoring, but it's more valuable in the qualification matches because of the way the points work to give yourself time to balance and make sure you can. And then I always tell the drivers, step back away from, don't touch once it's bounced, just stop. Put the controllers down and back away.
Step away from the keyboard.
Yeah.
Exactly. It's also interesting, I know that in the past there have been times when in previous competitions where the robots actually have to climb and lift themselves up 3 feet off the ground. When you consider this is a 150-pound, 125-pound device, that's not a trivial exercise.
I think most years there's been some kind of climbing task, but this year there wasn't, so there wasn't a point to make one. But yeah, in the past we've had to lift ourselves and even 2 other robots, so that's 500 pounds of lifting force. And that was definitely a tough challenge to package the gearbox to be able to lift that much weight effectively. We had one year we had wings fall down for the other robots to drive onto, and then we would lift them all up at the end.
Wow.
Some teams actually have used a sort of mechanism to climb onto the charge station that we have to balance on, and that makes it a lot easier for that team to get a triple balance. because they can just get 2 teams to balance on the charge station, and then the other one can just climb up and then lift to be off the ground, and then it's technically on.
Yeah, they had forks that would fall down and slide under the other robot, and then the whole robot would pivot on the forks to go up, which is a cool design that we didn't think of, but it's cool to see.
Yeah, there's that whole strategy of you got to put your cones and cubes in place, but then it's what other things, how are you going to collaborate with the other teams? Adds a whole nother dimension to the competition, which again is great. I mean, it makes it more complicated, but that's makes it that much more challenging when you finally pull together a great design. Another question.
You were able to hand the cone or the little plastic thing to the robot and have it take it and throw it or whatever it did. Can it pick it up from the floor?
Yeah, so with this intake design, we can pick up cubes from the floor and upright cones. And on our old intake design, we weren't as good at picking up cubes off the floor because it would kind of, unless you were perfectly aligned, it would spit it away. But with this design, it captures the cube better and is able to pick it up.
All right, well, unless there's any other questions, again, I really want to thank you for coming up here, bringing your design, and these are high school kids and doing just phenomenal work, so just congratulations. And I'd like to book you for around this time next year, all right? And so please come on back. So again, we have a rule here at Kopernik that you can't leave until you look through a telescope. However, tonight it's not looking that great. The haze just is really sort of taken over. So if you did pay to get in, if you see Sasha on the way out, we can give you a card to come back for free in the future. And we promise we'll have a paved parking lot by that point. It'll happen. This has been 30 years in the making here. So, but anyway, so next week we have the talk on Neptune, and then the week after that is the talk on the summer skies, and then finally Rocket Fest is coming up. So if you haven't already registered, go to our website. You can register to build a rocket and then come up here and launch it. So thanks again for coming and visiting us, and look forward to seeing you soon.